All right, today we're going to be talking about combinations. So last class or last video, we were talking about permutations where order matter. For combinations, it's the number of possible arrangements in a set when the order of the arrangements does not matter. What do we mean when we say the order does not matter? Let's picture behind my video here, there's a bunch of pool balls. Let's say that we have the full set of 16, including the cue ball, and we want to randomly select 3 of them. If we're talking about permutations, the scenario may be, hey, we win a prize if we select the balls in a certain order. So we get a prize if we select them in the order 1, 2, 3. We get the prize if we select them in the order 1, 3, 2, 2, 1, 3, 3, 2, or sorry, 2, 3, 1, 3, 1, 2, and then 3, 2, 1. They're all different. They count as a different outcome. But combination is when we're going to win the prize if we select those 3 numbers. It doesn't matter what order we get them in, just that we have the balls 1, 2, and 3, and so we get the prize. And that happens a lot. So if you think about just randomly selecting people for a committee, you know, like it doesn't matter that they chose Bob before Susie because Bob and Susie are both on the committee. Okay, so there is a fancy formula for it, just like there was for permutation. And just like for permutation, I'm going to show you the formula and how it works. And then I will also show you probably your preferred method, which would be typing it in Desmos. So our first example here, we have 5 books and we plan on to put only 3 of them on a bookshelf. How many different combinations are possible? So our books are labeled here A, B, C, D, E. Very original. Combination means that we don't care which ones, like I'm not asking you which one's going on the shelf first, which one's going on the shelf second, and so forth. We're just picking 3 of them. So I could have ABC, I could have ABD, ABE, ACD, ACE, ADE, BCD, BCE, BDE, and CDE in any of the orders. So like I could also mix them all up, right? So here's what the formula looks like. Again, remember I'm going to show you the formula, then I'm going to show you how to do it in Desmos. So bear with me. So remember factorial is when we are multiplying all the way down. So first step was just to say 5 minus 3 is 2. Write all that out as multiplication. Cancel out what we can. So I actually didn't put that on the PowerPoint, sorry. But the 1's cancel, the 2's cancels, the 3's cancel. So I'm left with 20 over 2, which 20 divided by 2 means that there are 10 combinations. Notice that that is how many combinations that I had in the beginning. And again, small sample space, it's easy-ish to write out all of the possibilities. Bigger sample spaces, it's not going to be feasible to do that. Yes, Desmos is much easier. You just have to type this in right here. So NCR, you can actually just type it. You don't have to go to the keyboard and functions that I showed you in the last video. In capital CR, if you don't do the capital C, it doesn't register it correctly. Then your parentheses, you want the bigger number first, then the smaller number. So 5 take 3, 5 choose 3. You type that in Desmos, you also get the answer 10. So these next examples should go pretty quickly. We're going to create a 4-person committee. So 4-person committee from 11 different people. And so how many different committees are possible? Again, we don't care who's selected first, second, third. We just want them all. I did do the math so that you could see it. I did not do the crossouts again, but the crossouts make this happen, which then makes it 7,920 over 24, which is 330 committees. Sorry. Again, do I expect you to do all of this algebra? No. So let's look at Desmos. Try typing it in Desmos. Make sure that you can type in NCR 11,4, and then it gives you 330. So combinations should be pretty easy today. And last, there are 12 standbys who hope to get on the flight, but only 6 seats are available on the plane. How many ways can they be selected? Again, don't care where they're sitting. They just want to be on the flight. They're happy to be on the flight. They're not worried about a window seat versus the aisle seat. I skipped the algebra this time. You get the idea. Type it in Desmos, 12,6 for 924 different combinations. So another one that gets big quick. Not as quick as permutations, but still, I don't want to make a list of 924 combinations. And I'm sure you wouldn't either. All right, so this 924 ways, and this ends notes on combination.